Solving one-step inequalities. An inequality is a problem in which one side is greater or less than the other side. The solution is the set of all numbers that make the inequality true. The symbol where the pointer points to the right means is greater than. If there's a line under that symbol, it means is greater than or equal to. If the pointer is pointing to the left, it means is less than, and if there's a line underneath, it means is less than or equal to. When the small part of the pointer is pointed towards the x, it refers to all numbers that are less than 3. It is read as x is less than 3. When the 3 comes first, pointer is still pointed towards the x, we have 3 is greater than x. This still means all numbers that are less than 3. When we graph this, since there's no line under the symbol, we use a hollow circle because we are not including the 3 in our answer. We are including all numbers that are smaller than 3. Less than is to the left, so all numbers that are less than 3 are to the left, and we color that side of the graph. In both cases, the small part of the pointer points towards the x, so in both cases we refer to all numbers that are less than 3. In the next case, we read the symbol as x is greater than 3. The mouth, or the large side of the symbol, is towards the x. This means we are referring to numbers bigger than 3. If it's written this way, we read it as 3 is less than x. But once again, the mouth is towards the x, so we are referring to all numbers that are bigger than 3. We do a hollow circle because there is no line under the symbol, so that does not include the 3 in our answer, and we color in everything to the right because the right side means greater than. Whenever the open side of the symbol is towards the x, color in to the right because it refers to all numbers greater. In the next example, there is a line under the symbol. This means it's read or equal to. This one is read as x is less than or equal to 3. This means that x is at most 3. This can also be written the other way round. 3 is greater than or equal to x. In either case, there is a line under the symbol, so we will include the 3 in our answer by making a solid circle. The pointer is pointing towards the x, which means that we will color to the left. We are including all numbers less than or equal to 3. In the next example, we read the sentence as x is greater than or equal to 3. Another way to say this is x is at least 3. Written the other way around, we can read this as 3 is less than or equal to x. In either case, there is a line under the symbol, so we draw a solid circle at 3. The mouth is towards the x, so we color the graph to the right, meaning all numbers greater than or equal to 3. When solving inequalities, we use the same steps we use when solving equations, except the answer will have an inequality symbol and will include a graph. In this case, we add 5 to both sides of the inequality. The solution then is x is less than 4. That means all numbers less than 4 will make the inequality true. Draw a hollow circle at 4, since 4 is not included in the answer, and color in to the left for all numbers less than 4. Now pause the video and try the next example yourself. Now that you have tried it, check your work. In this inequality, we have x divided by 5 is greater than or equal to -3. To isolate x, we must multiply both sides by 5. This gives us x is greater than or equal to -15. Our solution then is all numbers greater than or equal to -15. We draw a solid circle at -15 and color in the graph to the right of -15. All numbers greater than -15 or equal to -15 will make the inequality true. There is a special rule that applies only when solving inequalities, when you divide or multiply by a negative number. When you divide or multiply by a negative number, you must turn the inequality symbol around. Reverse the symbol to point the other way if you divide or multiply by a negative number. In this case, we are dividing by a -3, so the symbol turns around and points the other way, for x is less than -2. The solution to this inequality then is all numbers that are less than -2. In this example, we begin by multiplying by +3. This will not reverse the symbol since we are multiplying by a positive number. This gives us -x plus 2 is less than 21. Then we subtract 2 from both sides. This also does not affect the symbol since we are not multiplying or dividing. The last step, however, is to divide by a -1. When we divide by a negative number, we reverse the symbol. So our final answer is x is greater than -19. The solution is all numbers greater than -19. Now pause the video and try the last two examples yourself. Now that you have tried it, check your work. In example 5, we begin by subtracting 4 from both sides of the inequality. This gives us 3x is less than -6. Now we divide both sides by a +3. Since we are dividing by a positive, the inequality symbol does not reverse. This gives us x is less than -2. Draw a hollow circle at -2 and color in all the numbers to the left of -2. The solution is all numbers less than -2. In example 6, begin by subtracting 9 from both sides of the inequality. This gives us -2x is less than or equal to -10. Now divide both sides by -2. In this case, we're dividing by a negative, which means we must reverse the inequality. For x is greater than or equal to +5. Draw a solid circle at 5 and color in all the numbers to the right of 5. The solution of this inequality is all numbers greater than or equal to +5. Please refer often to these notes as you complete your homework. Thank you.